Hi, welcome back to my channel. My name is Gina. In this video, we're going to talk about something new in my channel, Calculus 2. And I'm going to start with area estimation. If I ask you to find the area of a rectangle, it's simply the base times its height. How about if I ask you to find an area between a function f of x and the x-axis? Given a continuous function f of x over interval a to b, how does one evaluate the area contained under f of x and above the x-axis within a to b? That is, we want to find this shaded area. We're going to estimate this area using the Riemann sum. And here are the 3 steps. First, we're going to split the interval a to b into smaller subintervals. Then we're going to select a point within each subinterval and use the function's value as the rectangle's height. And lastly, we're going to add up the areas of these rectangles. And we denote this as sigma, which is the summation symbol of the base of each rectangle times the height of each rectangle. Let's look at this example. I want to estimate the area under the curve 2x minus x squared over the interval 0 to 2. So we follow the 3 steps. The first step, we're going to split the interval into subintervals. I can split this into 4 equal subintervals. And the width of each rectangle is 2 minus 0 over 4. So each subinterval has length 1 over 2. Then the second step is to find the y values of a point within each subinterval. Here, for example, we can take the right side point of each subinterval. So let x1 equals to half, x2 equals to 1, and x3 equals to 3 over 2, and x4 equals to 2. So now we're going to find the y value at x1, x2, x3, and x4. So we substitute the x value into the function 2x minus x squared, which equals to 0.75 for x1, and x2 is at 1, and its y value equals to 1. For x3, f of 3 over 2, which equals to 0.75. And for x4, we want to find the y value at 2, which equals to 0. So we just found the y values at this point, x2, x3, and x4, which are 0.75, 1, 0.75, and 0. So the third step, we're going to sum up the areas of rectangles with the base 0.5, and the height is the y values at these 4 points. That is, the first rectangle will have base 0.5 and height 0.75. The second rectangle will have base 0.5 and height is 1. The third rectangle also has base 0.5 and it has height 0.75. And the last rectangle, the height is 0, so it doesn't contribute to the area of rectangles. So the third step, we're going to sum up the area of these 3 rectangles. and we denote that as sigma base times height. Which equals to 0.5 times 0.75 plus 0.5 times 1 plus 0.5 times 0.75 plus 0.5 times 0, which equals to 1.25. However, using this method, if the function f of x is negative, then we will get a negative area. But what does a negative area mean? A Riemann sum is actually a sine area calculation, which means the area above x-axis will be positive sine area, and the area below x-axis will be negative sine area. And the Riemann sum is not the sum of area above and below x-axis. So in short, we will get a positive sine area when the function is positive over an interval I. And we will get a negative sine area when the function is negative over an interval I. That is the end of the video. I have a course on the complete section of area estimation. I'll put the link down below and it's free to enroll. It also has an assignment at the end of the course with solutions for you to do some hands-on practice. If you like my videos, please subscribe to my channel and like my videos. And I'll see you in the next video.